Alright, so today I want to start a new series on implementing a compiler, and this time we are going to implement a stack-based programming language. And yeah, if you remember from last time, a few months ago, we had like a programming language that was taken from a Stanford course, I guess. And to be honest, I don't really like object-oriented languages, but I thought that, well, for like a first compiler, it makes sense to take a language that's, let's say, specially created for a compiler because it's a compiler course. So yeah, I thought, well, probably it's gonna be really straightforward on how to implement the compiler. But for this language, I saw a while back some stack-based languages, and it seemed quite fun to like figure out how to solve problems with a stack-based language. And I think it's also gonna be easy enough, such that we won't struggle that much with designing the language because it's gonna have really basic instructions. And the way it works is pretty basic. So yeah, that's my hope. And this time, well, for the cool language, how we implemented the compiler was we did the full Lexer, then for all the tokens. Then we did the full parser for everything, building the AST for the entire language. And only then we went into optimizations and actually generating the assembly. That's like one way to do it. And the other way to do it, how I want to try it this time, is to try and implement as little instructions as possible and just go as fast as possible to the assembly, right? Just so we get the like hello world as fast as possible. And both of these methods work, like make sense. Someone commented in one of these videos for to try and have a vertical slicing approach, which is what I described, trying to get as quickly as possible to the assembly. But yeah, I mean, I think in the cool compiler case, it made sense because the language was already designed and I already knew it's gonna work. But for this stack-based language, I think we can do something like implement the stack, which obviously we need that, and then implement something like the math operators, right? And try to have that, and maybe input and output or something like that. So that's kind of my idea, right? And then once we have the basics, we can try to add more stuff like graphics, or I have no idea, but you get the point. Like we try to get the basics like math operations, and then we can add strings, we can add the if and else statements, for loops, if that's even possible in a stack-based language. We'll figure that out. We'll see if it's possible. So yeah, that's the plan for today. So let's start by creating the stacklang C folder for our project. Not sure how it's gonna be called yet, but we'll see. And I think I want to create a flake just in case. Yeah, because I want to make my life harder. Oh, honestly, I should have changed it first, maybe. Let me just... I don't know if you're supposed to cancel it, but who cares, to be honest. Yeah, so I can just copy paste this guy. Well, yeah, this one should be good, like the one from the cool compiler actually. So all it does is have some dependencies. We add the dependencies here, For core compiler I needed really because we added graphics to that language, so yeah. But right now I don't think we need any dependencies. Maybe Clang for the compiler, but it's already installed. I don't know if I should probably add it like this. I think it makes sense because, you know, if someone tries to use the thing, maybe they don't have Clang installed, or for some reason, I don't know, could be possible, who knows. So we can just nix develop, right, and then we can start with the like makefile. Oh, I added, strange. I guess it makes sense, but yeah. Anyway, so I guess I'm gonna use Clang for the, oh yeah, and obviously let's try to use C, right, for this project. I mean, I could use any language, but I mean, in my opinion, C is the easiest language to follow in a video. Like, sure, maybe, not sure what other languages are as easy to follow as C. Like, for sure, Rust is not easy to follow. Maybe JavaScript is easy to follow as well, but who would want to write a compiler in JavaScript? I mean, honestly, I guess when I say JavaScript, I actually mean TypeScript, because who would use JavaScript? Okay. Like, who would use the unupgraded version, right? Not trying to be... Okay, so let's see. Yeah, I mean, should we... I don't really want to, you know, copy that much stuff from the old compiler, but I think that, you know, kind of the makefile, I'll take it. So let's see how we can use Clang. I don't think I use Clang. It's the same thing as GCC, right? Yeah. Yeah, I mean, no, obviously it works. So yeah, that means we can actually start. So I guess the first thing that we need is some kind of example for the language, so that, you know, we know what to try to lex. So let's have example dot sl from stack language. I don't think it's something from yeah. So think let's think about it. Like, would make sense. Imagine that in a stack-based language, right? When you well, yeah, we can try to imagine that this is a stack, right? So imagine that you have some numbers, right, 2, 3, 4, 5 in the stack, and then you apply like plus, like addition, and plus usually takes 2 operands, right? And in a stack-based language, those 2 operands would be the top of the stack, so the first 2 things, right? So if you use a plus, it would take the first 2 elements from the stack, add them together, and replace that with the result, so 5, right? So that's the idea of a stack-based language. You take the first, or I guess depending on what function you use, you take that many operands from the stack, you do the function, and then you put back on the stack the result. And yeah, as I said, we'll do just math operations at first, just to get a feeling for how a stack-based language works, and then we'll add stuff like dupe, which I know it's popular in stack-based languages. And dupe, what it does, it takes the first argument and places 2 of them on the stack, so that's gonna be interesting. And there's also stuff like rotate or something, or swap maybe. swap, which takes the first two and swaps them around. That should be interesting. Yeah, I mean, even rotate. You can imagine it takes the first three elements and it puts the third one on top or something. I don't know. So I guess you can do all sorts of stuff with this, like in some instructions for stack-based languages, right? But the idea for now is gonna be just to have math operations. I think we'll do just that. Probably Boolean makes sense, like equals, right? And then you have true. And then maybe it's like if, something like if it's true, then you take the first one, otherwise you take the second value or something. But yeah, I don't know right now, so that's why I said, we'll try to figure out how to do if else, or how do we want to implement if else, if that's even possible. I don't know. So yeah, and how is the syntax gonna be? So I think that if you write 2 and 3 like this, because I was thinking maybe you want to put like 2 and then push, like push on the stack. But maybe you don't even need to specify push. Maybe just writing a 2, it means that it's on the stack. And then writing a 3 again means it's on the stack. And then if you put a plus, it means you want to add these two together, right? And maybe we can have something like output or print or show, I don't know, which takes the first element on the stack and prints it. Yeah. But I think it's going to be interesting if we want to add strings, because if you think about it, we can use the stack as characters, and then strings would obviously be like really difficult to use. But the other option is to actually have literal strings, like hello world is now on the stack, and then you do like print, and this thing will show hello world, right? So yeah, but yeah, it's going to be interesting. How do we actually, because this thing, if you think about it, 2 3 and then a plus will leave a 5 on the stack. So our stack at the end of the execution is going to have a 5. So I think that what we want is that the last element that's left on the stack, right, it's gonna be the return code of the program, probably. So I think that's how we want to implement it. And sure, we'll do some static checks that the program only has one element on the stack, so you always have to consume everything from the stack except the status code. So this would be the minimal program, right? 0, which returns a 0 status code. I think that's how I'm thinking about it. And yeah, it's gonna be also an interesting problem to see how we actually simulate the stack. Like, I'd like this language to be compiled, obviously, not something interpreted. So yeah, probably the stack is just gonna be just the like literal stack of execution, right? That makes sense. So yeah, it kind of makes sense. Or maybe even have a separate place in memory for the stack, just because we can have strings, for example. So that could also be a point, like having a literal, like a place in memory for the stack, because yeah, you also have to think about stuff like what if we have function calls, right? Then we need to use the stack, like the literal stack. So yeah, probably we'll use some place in memory for the stack. But you know, let's see. Let's actually start with the interesting part, right? So if you watched, I mean, it was pretty recent, the PDF parser. Let's see the PDF parser. If you've seen this one, we did a pretty basic Lexer, right, for this programming language, like for PDF. Well, no, wait. It was for JSON. I'm sorry, it was for JSON. Yeah, for JSON we did a pretty basic Lexer, right? Oh, which is cool because I added that into ds.h, right? So, but you know, we cannot, like, it doesn't make sense to use that because it's not not useful. But it's like in ds.h we have an example of how to use a Lexer. I lost it. Okay, it's here. Okay, perfect. So we had all of these tokens for our, obviously for tokens. So you can imagine that in this stack language we'll have tokens for numbers, for math operators, right? And then we have some structure, and then we have the Lexer, which is kind of the same, right? And yeah, I mean, we have some stuff that we can try to reuse from here. So yeah, let's actually try to get something similar to this thing, right? And probably to make our lives easier, we can use ds.h because ds.h has, you know, some cool data structures. Okay, so we can just download ds.h, right? And now we have, I guess, the latest implementation. It contains also this JSON parser. So if we go to the implementation, yeah, like, why not? We can just, you know, copy stuff from here. But first, let me just make sure that everything works. So how do we do that? Well, find this implementation, and then we can include ds.h. And instead of printf, let's use like ds log info. And yeah, like this stuff, yeah, it uses some kind of formatting, but it's, you know, it's not important. So yeah, I would just copy paste this first thing, and obviously we don't need the entire ds implementation. We just need some things. Probably we'll figure out what we need on the way, but yeah, let's think about it. So I prefix most of the things with stack. It's like stack lang or slang, I don't know how we are gonna call it, but it's gonna be easy to replace, right, if we decide on a name. So what do we need for now is number tokens, right? Another important token is end of file, which specifies that, okay, we, like, this is the end, and token illegal for stuff that doesn't work, let's say. So yeah, and for now I'm just gonna try to parse this like with a single number, and that number means the status code of the program. I feel like in a weird way that's where we need to start. All right, so next thing is the stack token structure, and this data structure is going to have, oh, I need to rename this as well. Okay, so this is gonna be stack token. I can actually do something like this. Interesting. Didn't really realize that you can have like an anonymous structure. Anyway, so we'll have a stack token kind, right? Is gonna be one of these. It's either a number and a file or illegal token. Then we'll have the literal value, so as a string slice. And for string slice we need, because obviously we'll use, it's SS implementation. That's in the docs of the SH, but yeah, we need a string slice and the position in the code. And the position is useful for reporting errors, for example, like illegal token, character, whatever, right? Obviously we can convert this position into line and column, which is more useful than just the index of the character. But yeah, and then the next thing is we need the Lexer structure, and the point of the Lexer structure, we can call it stack Lexer, is it's gonna hold the state of the input buffer, let's say, and at what position, like it's going to hold the input buffer and the positions where we are currently in that buffer, like what character did we reach, right? So you can see that a token has this position and then the Lexer also has this position, so somehow, you know, we need to match these together, right? So yeah, kind of the idea. Lexer is just the state of the input, kind of. Right. We want to get the parser, right? We can start with the Lexer and see some like tokens. Sure, that would be nice for printing, but I don't think we need it. And usually the way I go with the Lexer is kind of the following. I have these two functions, Lexer peak, which the point of Lexer peak is to take the character from the read position. So yeah, these two positions, right? We have a read position and a position, but obviously it's gonna be a bit weird. Read position is just position plus one. So yeah, so you're gonna say, okay, but why do we need then these variables? I think it's just more intuitive when you look at the code. So it's like, oh, let's take a look at the read position. Well, if the read position is more than the buffer length, then the current character is end of file. Otherwise, we just look at the read position, right? So that's the main idea. And then when we have the next, like this function just gives you the current head, right, of the input. This other function, the stack Lexer read, the point of it is to advance the Lexer. So we get the current character from stack Lexer peak, we get the current character, and then we advance the read position by 1. So we say, okay, let's go to the next position. And again, we use this Lexer ch just again to cache the current character. So for example, if you run Lexer read, all right, you can check this ch attribute or field on a structure, and it's gonna tell you what character was read. But I mean, this function also returns that thing, so it's yeah, kind of what we need. Okay, so another cool function is this skip white space. It's a quite useful function because I guess in our language it doesn't really matter how much white space you put around or how you format your code. It's always gonna be like numbers and then operators, so we kind of want to skip white space and ignore it. It's not like Python where you know, white space matters. So how this function is going to work is we'll check the current character, and if it is a space, then we skip the Lexer, right? We skip one more character. And I think, yeah, that's a pretty good start, right? Obviously, we also need to initialize. I mean, I know it's a bit of copy pasting, which I'm curious if it's possible to somehow avoid in a weird way. Like maybe, like sure, I guess would be possible to somehow have this part of the code from ds.h a bit more like generic, but would require a lot of changes. So if you think about it, in C, right, we can use void pointers, and that's like a really cool thing. I guess I could explore and explain to you guys how like using void pointers in a, like, if you think about it, there are two kinds of languages, right? Dynamically typed and statically typed. And there's also this concept of weakly typed versus strongly typed, right? And void pointers actually kind of make the language look a bit more dynamically typed, right? If you think about it, it feels a bit more like you can use any type when you do void pointer. So that makes C weakly typed. So it's in this category of it's statically typed, but it's also weak, right? Compared to something like Haskell, where one type just means only that type, and you cannot change it to void pointer, and then like you cannot change a string to a number. In C you can actually do that, but you know, and I'm not talking about converting a string into a number. I'm just saying exactly taking the part of the memory and then interpreting it as a number. So yeah, I guess interpreting is the right word here, right? You can interpret a type as another type, and that makes the language weak. You know, it's not like weak as it sucks. It's weak like in you have more room to play around with the types. Yeah, anyway, so let's continue with useful stuff actually. So as I said, we need to initialize our stack Lexer. So this should be like the entry point to our Lexer. So let's call it stack Lexer. It's gonna take the stack Lexer, the character buffer. Yeah, I mean, I'm gonna try to refactor this stuff somehow, but not sure yet. And then yeah, so obviously the initialization function is going to take in the string and the string length, right, that we want to lex, to tokenize, and just initialize these variables, right, to 0 and everything. And the first step is to just read the first character. Simple enough, right? So we just fill in this first character and set the position to +1. It is straightforward, I would say. So yeah, now if we check the ch character, we actually have a character. That's the point of doing a read first. All right, so then we have some utils functions, right? Oh, tokenizing a number might be useful. Might be useful indeed, but let's first go to the next function that is gonna be, let's say, public in a way. Yeah, probably I'm gonna split this project into multiple files. So let's say I'm gonna remove these statics. So yeah, if you think about it, these are just private functions, right? They're not really needed outside, but initializing a structure, obviously, and also doing calling next, I would say probably, not sure yet, but we'll see. So stack Lexer next. Right. So this function, you can see that it takes a Lexer and a pointer to a token. So what it's gonna do, it's just gonna read from the Lexer until it can build a token. So let's look at our example.sl. So let's say we have a 0, that's only one character, right? So you say, oh, but we read only one character, but what if we have 1, 2, 3, 4? Right? This entire thing is a token. So in this function, we want to make sure that we read as many characters as possible so that we build a full token, right? So that means, well, obviously first we need to skip all the white spaces, and let's see what we need to do next, right? So here I was saving the position, and the reason for that is in case we have an illegal token, would be nice, to save the position, but position is going to be useful for all tokens. So yeah, and then we just need to do this if stuff. Let me just copy one of them just so we have it here. So if the current character is end of file, you can see that it's used here. So when we reach the end of the buffer, we actually return end of file. Right, so if we encounter that character, then not sure why I did a read here. It's kind of pointless, but I mean, maybe just to keep the same like formatting or something like that. Yeah, sure, whatever. So then we want to stack token end of file. I thought, oh, I was talking about them, but I forgot to change them. Okay, so we want to initialize this token with token end of file. Its value can be 0 or null, I guess. I mean, probably it's Oh, I mean, it's a string slice. Okay, so it can be like 0, like it doesn't matter. And then position is position. And yeah, why did I use a string slice here? Well, if you watch the JSON video, you notice that sometimes we were allocating strings and we weren't really able to free them for some reason. So a string slice is gonna be actually a pointer into the input buffer, so we don't allocate any memory for this one. It's a bit more like I would say it's not that safe, because if you free this buffer, then this is gonna be just garbage. But at the same time, is the reason why I would say C is like probably better in memory, like because you can just do it manually. You just do manual memory management. You know, you cannot, I mean, probably you can do that in Rust or other languages like that, but at the same time you cannot really beat a language that can do manual memory management in efficiency. So yeah. But at the same time, it's not really about efficiency. It's just because I implemented this string slice structure and I know it's really easy to work with. And in my opinion, less pointers is less struggle. I mean, this thing is still a pointer. Like if you check the structure, it's gonna have a pointer, but it looks like it's not a pointer, if you know what I mean. Like it looks like it's just a variable, so it makes thinking a bit easier. Right, so the next step, obviously we don't have brackets yet. Maybe we'll have, who knows, like arrays and stuff. So the next thing would be to look for digits. Right, so let me just copy paste this, and now it's gonna be interesting. I don't think we'll use a dot for now. I think we'll have only integers. So I mean, we'll look for digit or a minus. I think fair enough. Let's also do negative numbers. But yeah, I mean, I think that should be it. Right, and here we try to tokenize an int, or I guess a number. I don't know. We'll see. Like in the future, maybe we'll have floats, but right now, yeah. Okay, so let's just copy paste this function. Right, like this function is supposed to give us, I have to change a lot, stack. Like this function is supposed to read a full number. So yeah, now we are gonna check out how we are gonna do that. Right, so here we look at the first character, and now we try to parse a number. So the first thing would be to check if this function probably was called correctly. So we check if the first thing is a digit or a minus. Let's just correct that. Failed to parse number, expected. But this is more of a, cannot really happen. But yeah, it is what it is. Usually the Lexer shouldn't throw errors, right? But I want to use this function. Like, what if you use it outside of this context, right? And you are trying to parse a number without checking this condition first. right? So I just want to make sure that it's nothing weird happens. So this should be unreachable basically. Right. Then if we actually are parsing a number, see, we create this string slice which starts at the current position and has a length of 0 currently. Then if we find the minus, then it's a negative number, and we increase the length by 1. Then if we find dot is not going to be needed, as I said. Alright, we are just gonna look for digits at this point. Just gonna look for digits. If we find digits, then we increase the length with 1, and we read another character. And at the end, when we are done, we create a new token with the type of number, and we pass this value of the slice, which is going to be the start of the buffer, and the length is going to be, you know, how many characters we were able to read. And yeah, the position is going to be the first character. So see here, we save the position and we set it as the first character. If I think about it, the position could also be set once using this variable. So imagine we won't do this part, we won't do this part, and we just set it down here. I think that's also fair to do. I'm just thinking that maybe, but yeah, no, yeah. So yeah, I could actually do that. But I mean, I don't think I'm gonna do that. I think, you know, it makes it more obvious what happens. Like, it is what it is. So let's go here, right? And on the else case, obviously we have the illegal part, right? So what would happen if we read anything else than end of file or a digit, like a number? Well, we create a string slice at the current position, and the length is going to be 1 because it's only one character that's illegal. You know, we can imagine that you found an illegal character. Okay, let's ignore it and go to the next character, and let's try to continue from there. All right, so yeah, and we have stack Lexer read. So we skip the illegal character, and then we create we initialize the token, right? And see here, we return a 0, and that's because, again, we don't want to say we got an error in the Lexer. We just want to say like the Lexer should never fail, right? The only reason why, again, I said here, it's this thing should be unreachable, but right, it should be unreachable, but who knows? Yeah, and the reason why I want this thing to return an error code, even though it shouldn't fail, is maybe we'll have stuff like memory allocations required in this function. So then if a memory allocation fails in the future, when we'll need that for strings maybe or something like that, then yeah, we need to say something about it. Okay, anyway, let's see what else we can copy from here. Let's say this function is a cool one. like JSON Lexer position to line and column. It's a pretty nice one. Obviously freeing the thing. I think it's another interesting function. Right. I mean, it doesn't do anything, but yeah. And yeah, like it's gonna be interesting because right now, if you think about it, we don't really need a parser. Like the point of the parser is gonna be just in case we have if-else statements. But for a stack-based language, I'd say you don't really need a parser. That's weird. Yeah, like you don't need an AST. But we'll see. So yeah, we have the basics going, right? Let me just make sure. Yeah. I mean, I would also copy this one. This is nice because you can convert the position of a token to line column. So if you want to report an error, let's see where it's used because it should be used somewhere here. Yeah, in the Lexer, right? If we try to report an error, we have to convert the position to line and column. I mean something like that. Okay, so let's see now in json.c. Probably in the main function. Oh, you know, maybe it makes sense to use argparse as well, and IO obviously. So let's have that here. So argparse is an argument parser. If you want to see more about it, I guess I'm not sure, like probably any, like maybe most of the videos I do use argument parser. So this is also data structure from ds.h. So let's just say stack lang. Maybe it's gonna be called stack or stackle. Stack. So yeah, we create the parser, stack lang compiler. Right, we create the parser and then we add some arguments. And for example, this is how you specify the arguments. And this input file is a positional one and it can be optional. So if you don't specify it, it's gonna be null. If you specify it, it's gonna be that string, right? And here we parse that and then we assign. I just decided to have like a small function that is going to do these arguments. I mean, we could even have like the Python way of doing it, you know, like a crazy type def structure args trs or something, and then char pointer file name, And in here, let's say instead of that, we get the args pointer args, and here we do args file name is equal to that. Right, so now we have a structure for the arguments and like actually parsing it. So, yeah, I mean, decent. So here, for example, we need this argc and argv, and then we can have the args, let's say it's equal to 0 just to initialize it, and then we can do arg parse argc argv, and then we do a pointer to args, and this thing can fail, so let's do int result is equal to 0. If this thing is not 0, then we return defer 1. Is it how I used it? Yeah, something like that. Something like that. I mean, fair to parse arguments is a fair thing, and then defer result. Right, so here we try to parse the arguments. Now if we compile, run main, nothing happens. If we do help, it should actually show us the help screen. I mean, it's really cool. Right, so you can see input is optional and is the input file. So if you do something like example SL, it's gonna set that as the input file, but right now we don't use it. So let's do something like this. Args dot file name, right? We use file name, and for this one we actually use ds io read, which is going to read this is the path, this is where we put like the buffer, this is the mode, so read, simple read. So let's have char pointer buffer probably equals to null, and what does this thing return? Information, I think it's an int or unsigned int. Unsigned int buffer len. Yeah, I mean, it's just an integer, but oh, I guess, you know, it makes sense because it should have the same type like the Lexer init. Where is Lexer init? Oh, yeah, whatever. I think the point was that a result, right? So result is what we return. I think fread, I don't have it imported in the LSP. That sucks, but I think fread, no. Maybe it's about this thing, SB, like the dynamic array. But even dynamic array is unsigned. Yeah, I don't know. I just decided to return an integer there for some reason. I can make it unsigned. Yeah, whatever. So yeah, we try to read from the file, but you know, if you don't provide the file, then it's gonna be stdin, and if it fails, then you know, we just do the classic error and return it for 1. just to show the error. And here, just to be sure that we actually read something, we can log the buffer. So if we recompile, we find the 0. And if we run without anything, we can put a number and it prints it, right? So that's the idea. Okay. And yeah, here in the JSON example, I created some JSON load and JSON dump, right, which are wrappers around the Lexer. But I think what we can do for the beginning, it's stack Lexer init. Well, yeah, we need the Lexer buffer and buffer length, right? Let's define, I guess, probably it's also going to be like a function or something. So I'm just going to put them close to each other. I don't know, I think the entry point to the compiler is going to be getting the buffer and the buffer length. I prefer it that way because you can then create a library and compile from, like, you actually build a string in C and then you can just pass it into here. You then don't have to read it from a file. Usually I like this approach more, like the main function of a program is actually supposed to read a file and then call the entry point of the compiler with the string that it read, something like that. Yeah, I don't know. So now we can actually stack Lexer next, and we pass in the Lexer and a token. So let's do stack token is equal to 0, right? And if I think about it, this just foundation, I think I want this function to have it right now, or something like that. And the point of it is taking a token kind and returning its string representation. So for example, we don't have that many. Oh no, that would be cool to just do something like this. But yeah, we have only EOF, illegal, and number. Right. Whoa. I don't want to format. Yeah, I'll have to figure out how to set up a formatter, but yeah, so that's how we, because the kind currently is just a number, I don't think you can do stuff like this, right? Or do you have to put it everywhere to... Let's have different... Yeah, it doesn't work. I don't really know how you can... Yeah, anyway. I guess you can use const, but this is much better for switch statements. Okay, so let's see. So we can show the kind of a token like this, and then we have a string slice, right? So I guess we could also have a print token. I don't know if I have this function. I guess I have a JSON dump or something, but I don't think I have token dump. So we could do something like the same function from here, but make it for stack token to string, right? And here is gonna be just a stack token. And we try to make it a string. So what we need is a char pointer buffer for the string slice. This string slice to owned, and here we do something like token. One sec. So it's a point. Okay, let's use the token value, but it needs to be a reference and a reference to the buffer. This thing can fail though, but if it fails, then it's pretty much not good. So let's do something like, if it's not 0, then yes, panic, and this is also gonna exit from the program. So yeah, fail to create a string. I don't, like, shouldn't really happen, but fine. Okay, so after that we should be able to do something like, wow, ds string builder. I think we kind of need a string builder, because I want to combine this thing with this thing. So yeah. Oh, and the other part is that the end of file thing is 0 here. So how can we do that? Because this is just I mean, I could make a string slice with length 0. Which kind of makes sense. I don't know. Like, if you think about it, I could just do something like this and get rid of this issue. Alright, so basically it's the same thing as this one, but the length is gonna be 0 because we don't care about it, which is a bit sad, but it is what it is. So now end of file looks the same as this one, except illegal has a 1 and string and end of file has a 0. Yeah, anyway, so we don't worry about what to do there. And for string builder, how do I want to do that? Is a string builder. I mean, you can do an init, why not? I don't think it does anything, so wait, let's check. I don't think it doesn't. Yeah, it doesn't do anything. Oh, yeah, actually it does. It has a dynamic array. Ooh, it's gonna be interesting. Let's try to append some stuff to our SB. So the format, I think, is gonna be something like this for the type, and then in parentheses we'll have the value. So as I said, it's gonna be stack token to kind, and this should be token.kind, and then buffer. Right, if this thing fails, then again we can panic. It failed to format token or something. And then ds string builder. And we can I guess we can just ds free the buffer. Wait, what? I guess we can just ds free the buffer because it's not used anymore. Maybe even the buffer is equal to null, and then string builder build sb and buffer, and then we return buffer. And again, if this thing fails, then so if is not 0, fail to build the string. So something like this, and then buffer needs to be freed. So let's say this is a char pointer then. Yeah. So then we can do something like stack token to string, and then we pass the token. So let's see if this thing, so we have number 0, right? If we check in example and we do another number, get another number, and if we do like a percentage sign, it's gonna be illegal, and if we don't do anything, it's gonna be end of file. Yeah, so I'd say made some progress. Probably, yeah, I'm not sure if we want to do a parser. I don't feel like it's gonna be needed for such a language. I think the Lexer is all we need. So we might be able to just go ahead and do some assembly straight away and like try to get this this thing compiled, right? So the goal would be to read this number, well, you know, read all the tokens obviously, in a list maybe, and then try to build the assembly that returns that, maybe with some error checks that the stack is gonna be empty, like one element at the end. So yeah, but I think for today, you know, we made some progress, pretty happy with the progress, so we can try to implement that in the next one. So see you, and yeah, don't forget to like the video if you liked it, and see you next time.